In part 1 of our story of evolution, we demonstrated the facts of evolution. In part 2, we will explore the mechanisms. And to do that, we need to ask and answer just 2 questions. How does variety arise in the genomes of individuals in a group? And how does that variety give rise to new species? The first question is probably easier to answer, so let's work on it first. Let's start with the genomes of 2 individuals who are clones of one another. Their genomes are as close to identical as the real world allows. As these individuals live their lives, their genomes encounter viruses, which implant their genetic material into that of the host, thus making the 2 genomes no longer identical. The 2 genomes will also encounter radiation and mutagenic chemicals in the environment, which further modify their genomes differently. Transposons already resident in each genome will modify their genomes differently as well. The process of DNA replication isn't perfect, and the mistakes that arise in this process will further diverge the genomes. If these modifications happen in the DNA of the egg or sperm cell, then they are passed on to the children. In addition to those mechanisms for introducing variety into a genome, sexual reproduction has its own mechanisms to ensure diversity. This man has 2 complete sets of chromosomes, one from his mother and one from his father. But when it comes time to give a single set to each offspring, his 2 sets recombine in different combinations. The same is true for this woman. So when they have children, each child gets a unique combination from each parent. This greatly diversifies the genome of each population every generation. Now that we understand how variety can arise in individual genomes, we are prepared to tackle the second question. How does this variety give rise to new species? There are 2 major answers to this second question: natural selection and genetic drift. These creatures are Darwin babies, DAR babies for short, and they have volunteered to be test subjects while we study how they evolve in their environment. They are not strong, they are not fast, they are not poisonous, they are not smart. All they can do is hide. Predators exist in the environment, and the DAR baby that stands out is more likely to get eaten than the one that is camouflaged. Their genomes consist of 8 pieces of DNA, each piece contributing to the color of the DAR baby, like this. In each generation, 25% of the DAR babies get eaten by predators. Another 25% perish from random acts of misfortune. Just unlucky. Mating is completely random, and each DAR baby has a 50% chance of getting 1 random mutation. As you can see, almost all of this environment is random. The only tiny non-random factor is the predators eating 25% that are the easiest to spot. Will evolution really work? Perhaps. Evolution is a very robust phenomenon. We will start with all the DAR babies matching the environment. But the environment changes, and now they stick out. Predators come to feed. Some are just unlucky. The survivors mate. Mating is totally random, producing the next generation. Notice all the mutations, which are indicated by the green DNA bits. Some mutations are bad. Notice the Dar baby that is completely white. Many do almost nothing, and some are actually good. Predators come to feed. Notice how the really bad mutation causes that poor Dar baby to stick out and get eaten, while the really good mutation prevents the Dar baby from being seen, keeping him alive for now. Some are just unlucky. Oops, the Dar baby with the really beneficial mutation was unlucky and still died. How can evolution ever work? The survivors mate, producing the next generation. Predators come to feed. Some are just unlucky. This guy gets to mate 6 times, while this guy gets to mate only 2 times. Remember, mating is a random variable. Now sit back and watch the rest of the evolution unfold. 13 generations total. Surely that won't be enough. This guy survived to mate, and just because of bad luck, never found a partner. Remember, mating is a random variable. Did you see it happen? In an environment filled with random variables, a tiny bit of non-random competition, imposed by the predators, was able to drive evolution. If we were to repeat the simulation, but with a light background, this is what we would get. The environment biases the competition, thus steering the evolution. And that is natural selection. In an environment full of random variables, a tiny bit of competition is all it takes. Notice how the evolution is not smooth. Sometimes evolution appears to stop. Other times it moves fast. It can even go backwards. Yet over time, the net effect is a directed process, making the organisms more fit for their environment. The element of misfortune, unlucky dar babies dying without regard to their fitness, is an example of genetic drift, the other prime ingredient in the mechanisms of evolution. There are many more issues that scientists must pursue. Going by names such as punctuated equilibrium, bottlenecks, founder effects. But you have just seen how it happens. It really works. Common descent is a fact. Species evolve. Natural selection and genetic drift are the primary mechanisms.